Greetings everyone, today we will learn third chapter vectors. This would be the second lecture of this series. Third chapter vectors, lecture number second. So in this lecture, students, we will mainly discuss addition and subtraction of vectors and resultant of vectors. Let's see. Addition of vectors. Addition of vectors. And what is addition of vectors? There are two methods in which vectors are added. One is basically triangle law and the other one is parallelogram law. First we discuss triangle law. Triangle law and its statement. What it states? If the tail of one vector be placed such that at the head of the other then resultant R is drawn. Resultant R is drawn from tail to what, students? From tail of one vector to the head of the other vector. Right, students? Of one vector to the head of the other vector. To the head of other vector. Let me show you what I mean mathematically. So this is the statement. So a statement is not very clear in itself. If you could actually show us a diagram, actually what you mean by this statement, then we would be able to understand what you are saying. So R A plus B. A is this vector, students, and this is B vector. This is the resultant vector. So the thing here to be discussed is that B vector should be here and R is such that A plus B. This is addition of vectors, student. Resultant, as the statement goes, tail of the first vector A and head of the second vector B, of the other vector B. Okay, when you join both of them, you get the resultant. Now the second thing, this figure can be drawn in this way also, students. See, B I am taking to be here. This is B vector making same angle and everything, and A I am going to take towards here. A being here then resultant becomes where, students? Not here, sir, not here. You are doing it right, but not in a certain way. A happens to be here. Okay, this is A, this is B. Because the resultant should be in the same direction, na, students? Yes, students. Very nice. This happens to be the resultant. R A plus B, and this is A vector, this is B vector, this is R. So you must have noticed that R is having the same magnitude and same direction as in this case. Both are the same thing. A and B figure are the same thing. A figure and B figure are same thing. Second part of the story. What must be the second part of the story, students? Sir, you need to tell us how we would know. But what it could be? What it could be? Actually, it all says that resultant, no matter what, even after parallel transportation, remains the same. Note, resultant R does not change even after parallel transportation of vectors. Does not change even after parallel transportation of vectors. This is parallel sign, students. Parallel transportation of vectors. So this is the thing to be noted. Second, parallelogram law. Parallelogram law. So the triangle law we have discussed. Now the parallelogram law. So you would say, sir, is it the same thing as the triangle law? It is quite similar to triangle law, students, but here we will consider angle also. Whereas triangle deals with two vectors. This our parallelogram law actually deals with multiple. So here I want to discuss with you the angle property and other things of the vector. Let me write down the statement for you. Then we will understand that how this whole thing is working. The diagonal of the parallelogram gives what, students? Yes, the resultant gives resultant R of the two vectors A and B. Okay, making an angle theta with them. So angle could be anything, phi or anything, making an angle theta with them. So here angle use becomes important. It actually gives us the magnitude of the resultant vector in this way. Let us see the derivation, what the derivation means. See here we have A vector and this is what students? The B vector, right students, and this is going towards this direction, and this is, yes, this is supposed to be the resultant. This is the resultant R, which is A plus B. Is this the angle between both of A and B vectors according to the theory? No students, this is not the angle. This is not the angle between them. Alpha is being the angle, and it is not the angle between them. This theta angle is between them. How, sir? How you are saying? Because students, the smaller the smaller angle would be taken. Now this seems to be large, but yes, this is not the large angle, this is the larger angle actually in case. So what should I do? I should redraw my diagram and do what? I would take the tail of the first of the given thing and join with the head of the other, right students? Definitely, sir. But how, sir? Wouldn't it change the angle? Not much to the point you are thinking. B, A vector. So you see, A vector is being transported to here, and B vector from here is being transported to here. So it makes this angle theta. So you would ask, where did alpha go? So alpha actually remains to be alpha. I would now, in this case it was higher I have taken, but in this case it appears to be smaller. So it is not that about the magnitude of the vectors, it has always been about the tail end. Okay, first you need to satisfy the tail property, tail and head property of the vectors, and then you have to satisfy the angle property. Okay, so, and in physics, in symmetry, we see always that this property of angle and tail and head always complement to each other. So I would write magnitude of R is such that R A square plus B square 2AB sin theta. This is the magnitude of R, the resultant. Now you would again say, sir, this is not right. This is not right. You have actually written the magnitude. Where is the derivation of it? Let's see derivation now. Let's see derivation. So, as I said, after transportation, parallel transportation, we have B be drawn as this and A being drawn like this. So don't actually pay attention to the length, I would say. Not, I cannot be so correct in length terms. Then this R A plus B, and this is what angle, students, after parallel transportation? This is theta, yes. So this is theta. What are you saying? You draw the actual diagram and you are saying this is theta, alpha this is, and this is, sir, your theta angle. This is the real diagram, no? This is the first diagram, and this is second diagram. Yes. So this is makes theta angle here. And now let us see the derivation part. Let how the derivation theorem works quite fabulously. So let's see, this point N, this point is N, this is A, and this point is B. So this makes what? B sine theta along the vector, and this makes B cos theta. Where I am supposed to write it? Yes, B cos theta. Here I would write it B cos theta. This length here is B cos theta, this length here B sin theta along the vector. So in triangle ABN, what we have? In triangle ABN, ABN, this is the triangle. Okay, students. So we have cos theta as what, students? So cos theta supposed to be AN. Yes, very good. Right. Say AN, which is the base, and B the perpendicular. Very good. Oh, what I am saying, the hypotenuse. Yes. No, hypotenuse I have not written. B I have written. So hypotenuse is B. So our AN becomes what, students? B cos theta. Now the next part, what value we have to find? So we need to find the perpendicular. Yes, very nice, students. Sin theta is such that it happens to be Bn, and what is, students? Yes sir, the hypotenuse. Yes, then Bn happens to be B sin theta. Right, students? So we are understanding, but why we are doing all this? Why we are doing all this? To get the resultant, to actually get this value, this B vector and A vector in terms of theta, and to get this value in terms of theta and the resultant, we need to write this in triangle. Not in triangle OBN, which is the triangle OBN, students? Sir, here it is, OBN. So what I should write, students? Sir, you write anything you like. ON square, right? No, students? No, sir, not right. It should be OB square. OB square, ON square plus BN square. Right, students? Definitely, sir. Now it is right. Which property it is? Pythagoras theorem. Now the next part. So the next part says, now what the value of this is? OB. So its value is R, and which happens to be square, and this is A plus B cos theta from the figure. Okay, if you have written the figure, you might have noticed it. And this is B sin theta, sir. Right, students? Certainly, sir, certainly. Now square both the terms, we get r square as a square plus b square cos square theta. Then what should I write? 2ab, right students? Not 2ab, I should write here. Yes sir, not here. 2ab cos theta. Right now students? Yes sir. B sin theta square. B square sin theta square. Now what is the thing here? B square cos square theta. So of course b square. So I would write a square plus b square plus 2ab cos theta. Right students? That 2 square and this cos square theta sin square theta is what? 1. So this makes r as under root the required value, a square b square plus 2ab cos theta. Okay, so this is the resultant. Now the next part. So very beautiful theory, but if I have to say, if you would ask, sir, everything is fine, but if we have to find alpha, what we will do? If we want to find the alpha value, cos theta, of course you have find out in every way possible, but what about alpha being given in the original question? So what should I write in alpha? Now tan alpha is what, students? So it is Bn upon On. Right now students? And what should I write Bn as? So B sin theta from the figure. And this is what? On? So we don't know. OA An. Right now students? It is this value. On is OA plus An, and this becomes what, students? It becomes B sin theta, and this is E B cos theta. So this is tan alpha value. Sub beta, who will discuss beta from the figure? If you want to discuss everything, you discuss beta also, no? You wrote there in the figure alpha and beta. Where is the beta value gone? So let us see beta value also. If you remember the figure of original figure, then tan beta is A sin theta plus B A cos theta. Right now students? Definitely, sir. We can understand this from the figure. A special case that I want to discuss here. A special case I want to discuss here. So we have special cases also in this thing. Yes, certainly students. The special cases always exist. But the general formula does not fail most of the time in everything. If theta happens to be 0 degree, R is what, students? R is what? Maximum value, and it should be what? A plus B. This is the thing possible. If theta is 90 degree, then R is what? Minimum. Right, students, and this is taken to be a minus b, and this is theta happens to be 9. Sir, mistake. You might not have noticed it, but we have noticed it. 180 degree, yes. Theta 90 degree, and it happens to be 0. Sir, 0. And it should be in such a way 0 that the angle is becoming 0. And it is a square plus b square under root. So the next part, subtraction of vectors. What does subtraction of vectors say? Subtraction of vectors is actually the same analog of addition of vectors. Right, students? How, sir? How it can be the same analogy? This is b vector, students. This is a. Okay, and this is theta between them. Simple. To actually subtract the two vectors, what should I do, students? I should reverse the sign, na? That's good. Very nice. Very nice, students. I should reverse the sign. This is becoming a vector, and I reverse b vector in negative direction. This is becoming minus b. Right, students? So where did the resultant go? Where did the resultant go? So you tell us. Resultant happens to be in this way. Okay. Why, sir, it is going into this direction? Why in this direction? Because according to the theory, if it is minus b, not plus b, so it has to be opposite of r, original r, the resultant. So if has to be plus positive b vector, then the resultant remains r in this way, but it has to be in opposite direction, right, students? So that is why I am getting this r, right, students? So you see the beauty, the symmetry of physics. And where is the angle? So where is the angle? Angle remains the same, theta. Angle does not change. But again the symmetry law. Again the symmetry law of physics. 180 degree minus theta. 180 degree minus theta. And alpha beta, sir? Alpha beta. So beta is here, students, and alpha is here. Okay, students. So, so you have written resultant. Okay, I am changing the name R. I am giving it another name S. It has the same thing, resultant, but it is subtraction resultant. Okay, subtraction resultant, and it should be what? A minus b. Right, students? Subtraction resultant. Nice, sir, what you are saying. Everything is nice, but what about the formula? So let's see the formula of a minus b. So what should I write? This thing. Then again S is vector with, and this is minus b vector. Okay. Now do you calculate for now. While I am erasing, think of yourself now that what could be the subtraction vector, subtraction resultant vector. Thinking, sir, thinking. We have understood that you want to make us Sir Isaac Newton. But a square plus b square 2ab cos 180 minus theta. Right now, students? Sir, whatever you say. So, you were saying that the angle between them is theta and now you have taken to be 180 degree. So, again, what would I say? This is subtraction resultant, no? This is subtraction resultant. That is why I have taken the angle 180 minus theta. Otherwise, the angle, original angle of A and B is theta, and the minus B vector happens to be 180 minus theta. Then what should I write? Yes, sir, you should write as A square B square and cos 180 minus theta happens to be minus 2ab cos theta. So, this is the subtraction resultant vector. Okay. Sir, very nice, very smart, very wise. Mathematicians can do anything possible. So, this is the subtraction resultant vector. Again, the question arises, what is tan alpha, tan beta? Hence, I would write tan alpha, tan beta as what, students? B sine 180 minus theta, right, students? And what? So, we don't know. AB cos 180 minus theta, same thing, no, students, same thing I would write, but only the minus theta would come. Oh, sir, we have now understood. So, what should I write? B sine 180 minus theta is sine theta, and A minus B cos theta. Definitely, sir. Now, tan beta what? What should I write tan beta? Think of yourself now. Sir, the same thing will repeat itself and minus theta would come. Yes, very nice. Same thing, repetition, physics generally repeats itself with its principles, with its symmetry laws. So, it is like quite a repetition that nature shows to us in symmetry phase. A sine theta, this is tan beta value I am writing down. For you, you derive it yourself. B minus A cos theta. Yes. Now, Polygon law of vector addition. Polygon law of vector addition. Sir, this was little bit difficult. How we are supposed to deal with the polygon? It is quite interesting, student. Polygon law is more simpler rather than parallelogram law. Let's see how. Maybe I should make the figure here. A, B, C, C, D, this is E. Many people must have understood that I have changed the direction. What this is meaning? Where is A, sir? Where is A vector? A vector. Yes. So let's see the statement of polygon law vector. Let's see the statement. Here, meaning it states, first the statement, it states that resultant R is drawn from tail end, from tail, oh sir, from tail end of first vector to head vector to head end of the last vector of the polygon. Right, students? Of the last vector of polygon. This is actually the meaning of the whole thing. Now, the formula. So you would not do the derivation of it right now? Definitely. Derivation we don't need of this, thankfully. So what should I write into the resultant, students? So you write anything that you like. A plus B plus C plus D. This is actually the meaning of all of it. Right, students? And this could be the actually E side of the polygon, or E, not to write actually, but also note, but if the same polygon is in this way, okay, if the same polygon in this way, A vector, B vector, this is C vector, this is D vector, and this cannot be R, this is E vector, then of course is E or R cannot be equal to what? A plus B plus C plus D. Okay, students. So this is polygon vector. Now the last part of the theory. So what remains the last part? Is there anything else? Yes, students. There is one thing I would like to share with you that you might not have noticed in physics. While studying physics, many people don't notice this within the vector limits. They read everything but don't actually notice this thing. Note, if a physical quantity is a vector quantity, if a physical quantity is a vector quantity, and it has a direction, and it has a direction, and it has a direction, but converse may not be true, but converse may or may not be true, may or may not be true. So what do you mean may not be true? So let me show you what I mean. So time has a direction, it moves forward, but it is not a vector, right? It's in time moves forward, but it does not have a direction. But sir, time is one thing. No, there are other quantities also. If a physical quantity has direction, it may or may not be a vector. This is the thing. It may or may not be a vector. This is the meaning of it. It may or may not be vector. Okay, sir, we have understood your thing, but you have given only one example. Now let's see multiple examples. Example: time, pressure, surface tension, current, etc. There can be more quantities into the nature. We cannot add each and every one. And reason I am giving why they don't follow vector law, vectors being vector thing. Time is a scalar quantity, students. But here I am writing that it has a direction. So let me show you how. It is not a vector. Anything do not follow vector parallelogram law of vector addition, is not a vector. Law of vector addition is not a vector. Okay. Okay, so we have understood. And the last part of this theory. So this is not a theory, you are saying. Concurrent coplanar vectors. So what concurrent coplanar vector? It's supposed to be discussed into the last lecture. Yes, I have forgotten about it to be discussed. So will discuss it here. A vector, and this is B vector. This is y-axis, this is x-axis, this is the first plane, xy plane. Then what should I write? vectors having same starting point starting point and are coplanar and are coplanar are what? Concurrent coplanar vectors. Is okay. Coplanar means lying on the same plane. So our second lecture ends here. Thank you.